Hello students, today we see force between two charges when dielectric is filled. Consider the two charges at r distance and dielectric is completely filled between the charges, that is up to r distance, and force becomes 1 by 4 pi epsilon naught k q1 q2 by r square. Here k is not equal to 1 by 4 pi epsilon naught, it is the dielectric constant which is the ratio of the permittivity of medium to the permittivity of free space. It is also known as the relative permittivity. From this expression we write epsilon equal to epsilon naught k. When dielectric is completely filled between the charges, force becomes 1 by 4 pi epsilon q1 q2 by r square. Instead of epsilon, we substitute epsilon naught k and force is equal to 1 by 4 pi epsilon naught k q1 q2 by r square. Here the force is reduced by the factor 1 by k compared to the force between the charges in free space. This effect of decrease of force can be achieved by removing the dielectric and increasing the separation between the charges. Consider r dash be the effective distance to decrease the force between the charges, same as that of the force between the charges when dielectric is completely filled, that is 1 by 4 pi epsilon naught q1 q2 by r dash square equal to 1 by 4 pi epsilon naught k q1 q2 by r square. Here 1 by 4 pi epsilon naught q1 q2 by r square is the force between the two charges when dielectric is completely filled between them. This force is equal to the force between the charges when it is separated at r dash distance in free space or vacuum, that is 1 by 4 pi epsilon naught q1 q2 by r dash square. From this we write r dash square equal to k r square and r dash equal to root k into r. So this is the effective distance between the two charges to reduce the force, same as that of the force between the charges when dielectric is completely filled between them. If dielectric is present up to t length between the charges, then what will be the force? Consider the total distance between the charges is r distance. Dielectric is present up to t length. So up to this distance we consider r as root k into t, because we already know when dielectric is present up to r distance, the effective distance to reduce the force, same as that of the force between the two charges when dielectric is completely filled, is r dash equal to root k into r. If dielectric is present up to t length, that is if we place the dielectric t thickness dielectric between the charges, the distance, effective distance becomes root k into t, and remaining space there is no dielectric, so we take it as r minus t. So the total distance between the charges is r minus t plus root k into t, and force becomes 1 by 4 pi epsilon naught q1 q2 by r square. Instead of r square we substitute this, that is r minus t plus root k into t whole square. This is what the force between two charges when t thickness dielectric is placed between them.